Yeah, that's what
Yeah,
I'll present you the benchmark we are developing for LDBC, working publishing benchmark, and especially its current state. So, short introduction, this is an industry motivated benchmark. As Peter mentioned earlier, the BBC have provided us with some data sets and queries that we are going to integrate in this benchmark. The scenario involves a media publisher organization which maintains metadata about its journalistic assets, also called creative works. Those assets could be photos, articles, papers, books, whatever. The benchmark itself simulates the consumption of that metadata, or the updates of the metadata. Consumption of the metadata means that the users are just executing some queries or retrieving information. The updates of the metadata, these are the journalists who are modifying or adding or removing that metadata. Some requirements about the benchmark. First, the system must be storing and processing metadata. It should be able to load data in RDF serialization formats. These are actually all serialization formats are supported, but more important are MQuads, because the third requirement is to store and isolate the data in separate RDF graphs. Also, the system should support Sparkle 1.1 standards, RDFS, in order to get correct results returned by the queries that have been executed. And optionally, the benchmark tests the support of L2RL rules. There's several operational phases in the benchmark, which are executed sequentially. First one is initial loading of reference knowledge and data. The first, let's say, version of the benchmark, we used reference knowledge provided by the BBC only. But at the current state, we have decided to enrich it with DBpedia, person data, and also geonames for all countries from the European Union. Also, we have implemented adjustable loading of the reference data, which means that if we want to generate, let's say, 100 million or 500 million triples, the reference data that will be used will vary. Next phase is the generation of creative works. This is what actually the data generator does. It generates the metadata about the reference identities from the reference data. What we have added to the current version of the benchmark is parallel generation of the metadata, which could be done in multi-threaded or multi-process ways. Multi-threaded means that we can start several threads in a single test driver to generate the data, but we can also configure the driver, several benchmark drivers to generate in parallel that data. Next phase is loading the creative works. This phase is actually optional. It can be done by the test driver or it can be done manually because generated data actually is saved in files. So each vendor can choose how he can load it. We have a warm-up phase, which is standard for most of the benchmarks, just running the queries without recording the results. We have a benchmark phase that is actually recording the results. And the last phase, which is optional and which is not, which actually is run without the need to run the previous phases, is the conformance tests, which test the conformance to L2RL rule set. We have developed the benchmark to be as configurable as possible. There are a lot of options that can be set to the configuration file of the benchmark. It could be a number of aggregation and editorial agents, which means we can configure how many threads will do updates and how many threads will execute queries against the data. We can generate, of course, the size of generated data. At the moment, we are using time I mean, we can tune we can configure the amount of time the warm-up and the benchmark phases should run, which means we can say we want the warm-up to be 60 seconds and the benchmark to be 10 minutes or whatever. Each operational phase can be enabled or disabled, which means that we can just generate the data and stop, or we can execute just the benchmark phase, and provided that we have the data loaded in the database at some previous point in time. And of course, as I mentioned earlier, we have implemented parallel data generation, which makes the data generation process faster. Of course, we can configure the distribution of the query mixes. For example, the editorial operations currently are configured to have 80% of the editorial operations to be insert queries, 10% to be update, and 10% to be delete queries. Of course, this is tunable. We have the aggregate operation query mix also, which is configurable. Again, each query in the query mix is configured. Frequency of execution can be configured for each query in the query mix. Data generator can be configured. First, allocation of tax in creative works. These allocations actually were extracted from the live BBC data, so we are using live statistics for that. Of course, we have added to the data generator another two more models of data that are generated, so we can configure the clustering of creative works around the major or minor events, and also we can configure the correlations of data in the generated dataset. I will speak about the data generation itself. It produces synthetic data, which has the most characteristics of the provided data by the BBC. First of all, we have the input data, which are ontologies, again provided by the BBC, and reference knowledge datasets, which I mentioned earlier. They're enriched with DBpedia and geonames. Having that input data stored in the database, now we are ready to generate the creative works, or to generate the datasets. As you can see, all the creative works conform to the ontologies, refer to entities from the reference datasets, which means, for example, if we have politicians, datasets for politicians from the UK, those creative works are referring to those politicians. And they are following the predefined modeling and distributions of the data generator. Again, I mentioned this, we have analyzed the distributions from the live dataset provided by the BBC. So this is actually the evolution of the data generation process. At the beginning, we just had this random distribution, which more or less distributes equally. For example, we said we have the 1 year period, and we have the amount of creative works with tagged entities. So we have more or less a random distribution of all those tagged entities by creative works. So after we have implemented the additional modeling of data by the data generator, we have the clustering, the modeling of the clustering around certain events. Let's say, for example, you see the big spikes. This could be modeling, for example, the Olympic Games in Sochi. The event starts at some point in time and decays slowly. So we have, let's say, 5 major events per year and 100 minor events per year. It could be any type of news or whatever. And the next thing we are modeling by the data generator is the correlations. As you can see, we have for a certain period of time, we have entities which are correlating together, which means, for example, George W. Bush and Barack Obama are mentioned for this period of time together. And we can do some interesting queries about that later. I will speak a little bit about ontologies. We have core ontologies, which describe the basic concepts about entities. We have creative works ontologies, places, persons. All of those ontologies are provided by the BBC. We have domain ontologies that describe concepts about certain domains. like sports, politics, or news. This is just a sample of ontology, how it, what it looks like. We have a creative works ontology on this diagram. I'm not sure if you can see, but it has all properties and relations to other entities. I will speak a little more about the reference datasets. As I mentioned, these are collections of entities which are coming from various domains, like football competitions or Formula 1 competitions, UK Parliament people. And additionally, that we have added the geonames, places, names and coordinates, and also Wikipedia person data. And all these datasets, once stored in the database, they are referenced and tagged by those creative works later. Choke points. As you know, choke points are the technical challenges that each database engine should overcome to provide some reliable service. So all those constructs that you see that are listed here are part of the queries, and they are trying to identify and to put the database engine to some serious thinking. The workloads, we have simultaneous execution of editorial and aggregation agents. They are actually executing the query mixes. Editorial agents are executing insert, update, and delete queries. I mentioned the distribution that is 80% by 10 and by 10%, which is configurable. We have aggregation agents which simulate the retrieval operations performed by end users or maybe semi-automated systems. We have two query mixes. We have a base query mix and extended query mix. The base query mix consists of aggregation queries, simple search queries, count queries, full text search, and geospatial. The extended query mix is we have just implemented this part. It contains so-called drill down queries. So let's say we have geolocations of the entities, and we say we would like to have all the creative works which have happened around this location. This is the first iteration, and over again, over several iterations, we pick some of the geo coordinates of that location. We narrow down the circle, and then we get the next result, which consists of fewer entities, and then we pick another one, and so on. We have faceted search queries, which are more or less common nowadays. And we have timeline of interaction queries, which are executed against the correlated modeling of data that I showed you earlier. All the queries are saved in query templates, which means that they can be edited if required by some database engine. If we, for example, say a database engine does not support this type of query, or it cannot execute it the way it is presented, this query can be modified. We are using template parameters, which means that we are substituting, using parameter substitution in those queries, which is happening live at the moment. We are planning to have those parameters generated before the benchmark phase, and that way we will guarantee that the benchmark will execute consistently, because on every run it will execute the same queries with the same parameters. Metrics and result metrics and logs of the benchmark. We are measuring editorial operations and aggregate operations per second. Also, we are measuring the total queries per second executed. We have enabled, actually we have this as an option, but we can enable to have the fastest execution time for each query, the slowest execution time, and the mean average time. Also, the logs of the results are saved to files. We have brief listing of executed queries, which means that we have a list of queries that have been executed in their order. We have the detailed description of each query, which is actually the query itself and the result saved to files, so it can be analyzed at some later time. And we have a benchmark result summary, which summarizes the result actually, the benchmark. Integration, we have already uploaded the sources and datasets in GitHub repositories, although we have not declared the first draft of the benchmark. And we have adopted the semantic publishing benchmark as a part of the standard release procedure for Palm RDF store. At the moment, we are using to detect performance issues and deviations from future versions. Also, we have done some experiments with the Amazon EC2 instances. At the moment, our hardware is performing faster, no matter what type of instance we choose. Future work, by the end of April, we are planning to have query validation of results, which is important to know if actually the results produced by each database engine are correct. Query parameter substitution. I mentioned about this earlier. We need to have all the queries executed with exactly the same parameters substituted during each run of the benchmark. That way we will guarantee consistent results. And online replication and better features, which will be part of the benchmark. Thank you.
Are there questions or remarks?
Well, since you are benchmarking, but you are allowed to modify the queries,
yes,
which is the trade-off. For instance, you wrote on a slide that you are measuring free text search.
Yep.
And in Sparkle, you can make free text search in the sense that at least you can use regular expressions and that obviously, at least on average, each triple store is providing some kind of indexing that must be triggered specifically. So in these cases, are you getting the standard or are you getting the optimization?
It's up to the database vendor to decide if he chooses to use this index or not.
So you are not ruling
no.
as a...
At the moment, if the database vendor decides to utilize this index, it will provide better results then.
Well, I mean, full text index is very common. Almost any application has that. So the idea is to allow use of full text index and the geospatial index in this case.
Yes.
But of course, they should produce correct results. So then there's a validation check.
Yeah. So how much sharing is there between this work and the social network? Because I would imagine a lot of the validators or the substitution.
No, I don't think there is some sharing. I mean, we share ideas, concepts, but
like the drivers should be very similar. Because of Sparkle Query driver. And,
right. Well, the semantic groups, in fact, they were. I mean, because they were using the same. Actually, not. You evolved to the VSDN or
no, we started from scratch.
Right.
It's an opportunity to share, I would say.
Right. Well, we did actually find. Norbert did not talk about it in detail, but the cluster, this social network benchmark graph generation, so doing these insert queries at high data rate in the right order is in fact a difficult problem because. So we actually, for the social network benchmark, had to develop a new parallel client driver of its own, which makes it by definition different from this driver.
Do you have any estimation to separate communication overhead from execution overhead? Kind of figure out if you have a usage HTTP to the communication store, figure out what query is spent on.
Yes, the idea of the measurement of query execution is it starts at the moment that the client is. the request based to the start point and receive the result. This is actually the actual measurement time. And it simulates the real world use case. I mean, you just create some request.
So the client-server latency is included in the metric implicitly.
And there's no estimation done for what latency then is.
At the moment,
Client-server latency will not be very significant here. Not relative to execution time.
Depends on the platform. The platforms that we have seen so far, yes.
at least for the moment, we have tried on Amazon on our local hardware laptop.
The client-server part is 10 microseconds or thereabouts, and query execution on any platform is going to be more than that with the workload that we are considering.
Okay, thanks. And the advanced, well, there were some things that are still coming, so I guess this.
I mentioned.
I saw that. Yeah. Well, okay. Also tomorrow in our meeting. So thanks. Any other questions? No. Then we'll move on to the next speaker.